So, hey, friend, can you help me understand what this guy's talking about?
Small thing like in what they call an ESD or an endoscopic submucosal dissection. You have it done with an endoscope inside your bowel rather than chopping your whole bowel out. This is going to come thick and fast with a lot of metabolic therapies. It's going to come thick and fast with things like histosonics and histotripsy. It's going to come thick and fast with combination therapies where things like mRNA vaccines will be used in conjunction with ablation, in conjunction with histotripsy and things.
So, if you notice during this part of the podcast, I am smiling and nodding, but there are many things that our friend Steve Bell shared that I did not understand. And the whole purpose of this video is for us to work through this edit. And I have put these lovely blue markers here so we can watch a little clip, and then I can pull up Google, I can pull up videos, and I also have my lovely sketch pad here. And we're going to go deep in this discussion. It's a second sip to really complete a promise that I made to you. So let's listen to the promise and then we'll jump in. But yeah, let's listen to the promise.
With the coaching and global leadership. So a lot of people are outside of this world. So just a quick note to the viewers, I'm going to do everything I can to make the language of this discussion as inclusive as possible for you folks who aren't deep. But I want you to be able to speak freely with the right proper medical words and things like that. So at the end of this call, I'll go and do a list of definitions and links and descriptions. So if we're talking about a robotics company, we don't have to lose time defining everything. But I'll make that accessible to people as well. That way they...
Okay. So the whole goal of this video is accessibility. And for a little bit of context, I worked for Johnson & Johnson for over a decade, progressing surgical robotics technology. I worked across design engineering, robotics controls, systems engineering. I then went clinically facing when I relocated to Japan, where I traveled the region, attended surgeries, interacted with top-tier clinicians, and then ultimately ended up going all in on entrepreneurship. So I've worked across sales, marketing, business dev, as well as engineering. And I want to assume that you know none of this. So we're going to go clip by clip. And before we even jump in, I want to show you what this lovely individual, Steve Bell, worked on. This is a platform called CMR. Well, it's a company called CMR Surgical. The platform's called Versius, I think is how I say it. And this is a surgical robot. So we're going to start with a quick video of that robot. And then I'm going to go into what different companies are working on. And we're going to go clip by clip. It's going to be nerdy. It's going to be deep. But again, it's to make this conversation more accessible. If you haven't seen the podcast, go find it. There'll be a link in the description, I guess. Watch it in completion and then come and watch here just to dig even deeper and get that second sip of know-how. So let's check out what is Versius. Make this nice and big for y'all. This is their nice promo video. Naturally, it's going to be beautiful and have inspirational music with it. And then we'll rewatch it. I'll go through the features and then we'll jump into the podcast. Oh my gosh, it's so clean. It's just a nice edit. So pretty. Oh, that's good. Okay, so this is a surgical robot. Okay, so let me go to my tablet. Let me find my magic buttons really quick. Present the screen share. Then we have to accept it on this application. When we're going to do this live, it's going to be fun. Here it comes. So second sips with Steve Bell. Yeah, I'll just slide it off to the side. So there are lots of surgical robotics architectures. So if we look at Da Vinci, for instance, here's a nice table. Da Vinci is the major player in robotic surgery right now. It's got a little card, little table on the bottom. Putting way too much effort into the table. But anyway, you have your nice friendly person sitting here and they have cancer, and that's bad. And we want to get the cancer out of their body, and that's good. Da Vinci has this architecture where there's these two big, like, it's a boom. So it's a huge cart. It's got this big tower off the cart, and it has a crane that you can imagine up here. And then it has 4 arms that come off the crane. So you would push this cart as close to the table as you could, and then the arms have this kind of architecture that comes down and they connect to the patient. Put holes in the patient. And our whole goal is to go inside the patient, cut up whatever's killing them, and then pull out of the patient. Now, this architecture with the boom is kind of like what's been the gold standard for robotics for many, many years. And Intuitive has progressed it really well. And on the bottom section of this, if we kind of zoom in on an arm, and then I'll pull up a picture of Da Vinci because it might be easier. Again, you have different joints, and I'm not doing the joints full justice. This is connected to the boom. You'll have something called, Steve Bell uses this idea of a Z rail, a Z axis. And your tool will connect onto a rail that can move in and out. And this controls your insertion, which will insert the tool through something called a trocar. We're going to go back to that video to define all these things. Through a trocar, the tool will push through this trocar, which is sealed. And you have this gasket, basically. And the gasket keeps air insufflation inside the patient. So it allows you to kind of inflate the stomach so you have room to work. There's a camera that goes in so you can see as well. And then the tool is sliding in and out of the patient along the C-axis. Yeah, you can't have Play-Doh, buddy. I'm sorry. I'm parenting 2 kids in parallel to this. Daddy's going to regret this so much. If you give Play-Doh to a 1-year-old unsupervised, I will. All right, here it's on the floor. Go have fun. I'll pick it up. It's right there. This is the only pocket I have. And then this trocar is going to go into the patient's stomach. So let's pretend this is their belly button. Their head's over here. No, that's my phone. Look, they're very happy about surgery. And you can have multiple trocars stabbing the patient. It's not the clinical term. With multiple tools going in and out. And then there's different motors inside of here. So if you look at the bottom of an instrument, this is looking like up towards the shaft. You might have, I forgot how many stacks the XI has. Let's pretend it's 5. I don't know. There's going to be motors that can slide up and down the Z rail, but the motors will spin and that will move different mechanisms within the tool, which is super cool. I worked on these tools for Johnson & Johnson. So this is architecture 1. CRM. I gave you all the Play-Doh. Play with it. I had an interview at Chipotle. Buddy, I got nothing else for you. You want the lid? There we go. Let's keep rocking. Architecture number 2 that you'll see in CRM that we'll go through. Sorry, CMR. I always say CRM. I don't know why. CRM Arc 2. You have the same patient. Let's say he's very happy about this procedure. This is the architecture that you see for CRM. You also see it for a company called Medtronic, although there's differences between the two, Medtronic, Hugo, in which you have these carts. And then we'll go back to the video and I'll break it down. Cart 1, cart 2, cart 3. We haven't even gotten the console and all that. There's so much to cover, friends. So much context you're missing on this. But then off this cart, you can have your lovely robotic arm with an instrument that goes into the tool. Now, I believe, I have to double check. I think Hugo's architecture will still have that Z rail that pushes insertion in and out. I don't believe that CRM has a Z rail. They're trying to emulate the elbow and the wrist, so the architecture is completely different, which we'll look at. And then the third architecture, oh my God. Let's do all that. Karen. All right. The third architecture is you're going to go to Otava, which I will only share what Otava has shared from understanding. I have to be careful with this. J&J. So I worked on Otava for a decade. Otava's architecture, which is kind of fun, is you have this table, and you have a person, and we're going to say this person is really angry because patients have been waiting for far too long. It's taken J&J a long time to make this robot. And you have this lovely table. It's supported. And J&J has some special way of having arms that come up and over from the table. And there's certain clinical benefits of that architecture and certain challenges with that architecture. So the arms are actually in the table, and we could talk about the clinical benefit of that. I'll get into that. So this is the top. We're going to look at pictures of all this stuff. Then we're going to get into the podcast. But I think stepping back and understanding why these different architectures exist and why different companies are approaching robotic surgery differently is really helpful when we think about how do you innovate within this design space. So let's jump into the CRM video, and I'll just point at stuff now that you have these nice rough Joe sketches. And then we can start to look through the major players, and then we'll get into the podcast. All right, let's nerd out. So actually, this is a really good shot of it. I wish I could zoom in. So you have a surgeon who is controlling the instruments over here. This camera is inside the bubble, which is simulating the body. And you can see that CRM is leveraging this cart robot architecture. So it's not one big boom. We'll get to Da Vinci in a minute. And then you have your arm, and then this is the end effector. And in order to insert, the whole arm is pushing the tool in and out as opposed to it sliding on a rail. But what's also interesting, we'll get into different architectures for the surgeon control center. This is what's called an open console, where the clinician can view the surgical theater a little bit easier. They can interact with script techs and an assistant surgeon. Like in Japan, most surgeries have two surgeons present. One's at the table, one's on the robot. It's not, I actually don't know the difference in a US context. I think it's not as frequent, but you typically have double surgeons in Japanese procedures. So inside here, you have a camera that's also emitting that light so that you get nice 3D vision. He's wearing glasses so that he has depth of the surgical theater, like he can feel the organs and things like that. So let's see if there's anything fun if we replay this. And then we'll jump to the other companies. Then we'll jump to Steve. I hope this is helpful, friend. I'm excited to nerd out on robots for a while. So one of the first things is they've designed these robots to be light so that you can move them from room to room. This will be really helpful with something called, I forgot the acronym, ASCs, ASPs, like these smaller hospitals in more rural areas that are trying to do procedures, because you could leverage this architecture, like send a couple arms down the hall that are necessary and move them by elevator. I believe this is one of the only systems that has this small of an OR footprint and ease. So that moment would be super compelling. Also, the like rollers, that part. I love that. It's so freaking smart. So basically, like, if you've seen like big fire trucks that have a ladder, let's go back to my little sketch pad for a minute. This is just so smart. It makes me so happy. So some fire trucks will have, your wheels, but then they want to boom out a giant ladder people climb. Let's say it's a huge one. This also happens sometimes with like cherry pickers and stuff. They will have these arms that can come out from the vehicle and push into the ground so that it gives it a wider base, so it's less likely to tip over, and it gets the wheels, it creates a little bit of clearance on the wheels so that it's like solid before something goes out. Not every fire truck has this. Certain ones do. I think fire trucks do. Shoot, where have I seen this? Or it's a crane. I saw someone got stuck in a cherry picker like dangling when I was at college, and something did this. Some large vehicle can do that. Anyway, I love that they put this feature into these carts because they're trying to get just a slightly wider base and to make sure there's no way for it to tip or move once it's like docked on the ground. I don't know what's going on here fully, but I just love the thoughtfulness of it. Got your nice lights, cinematic, LEDs. Okay, so this is a trocar. This is going into the patient. Typically, they're called bladeless trocars, where they'll have a little plastic rib on it that they kind of twist through the layers of the, I'm not a clinician, like the epidermis, and then there's different layers between like your surface level skin until you get into the body cavity. They'll twist through all that, and then this will provide a seal. So there's normally a Johnson & Johnson's, they have the Excel trocar. They have this iris seal that it looks like a camera. Put up here. So inside, they have this seal that has these. I can't do it. There we go. So it kind of locks around the instrument, which will be right here. And then when you translate the instrument, this is in and out of plane, back and forth, it kind of hugs it. This is like a jelly silicone material. I don't know the exact material, but it allows you to have an airtight seal here. So you want to prevent leaking as much as possible so that you can maintain insufflation. So that's what a trocar does. And the tool would translate in and out. So you can see an end effector here. This is the tip. I think that's probably a grasper. Go back. That was a nice little shot. That looks like a needle driver, so you can sew inside of patient. Here's your nice console. It looks very different than Intuitive's. I don't know why. 3D glasses. And I'm assuming... Okay, dang it. It's too fast of a cut. Okay, dang it. Is this painful? There we go. So I'm assuming this portion is a disposable instrument. I mean, you likely need to have a certain amount of uses for it to be profitable. I'm not sure which instruments are reusable and to how many lives. I haven't looked into that. And then this would click on or dock onto the arm, which is capital equipment that you would use for every procedure. All right, that looked like it was camera. Yeah, so there's a way to lock these instruments on and off. I would love to see the interface here and what they're doing from a rotary motor perspective. But again, there's no Z rail. There's no Z axis to translate. So the arm physically pushes the tool in and out like a real surgeon's arm, which is what they're trying to implement. So you have your rotation axis. The tool is on the robot. And they're suturing in patient. I'm not sure why that guy's handling it, by the way. I mean, clinicians are going to be up next to your robot all the time. They get hit by robots. There's collisions that occur. Gosh, it's so beautiful. Just the amount of work that goes into this stuff is wild. LEDs are sharp. Okay, so let's look at Intuitive. I'm going to use the term gold standard here. Let's look up Intuitive Surgical. Let's look at the new one, DaVinci 5. Do they have a nice little demo video of it? Yeah.
Actors, we can make you believe we know what we're doing, when in fact,
I need to pay for YouTube someday.
Whoops, I have no idea what these buttons.
Okay, so this is the top of the boom. This is, I think, to help them with positioning the robot, like guidance on the patient. That's the new surgeon console. It's still a closed console, so you're really deep and immersed.
DaVinci 5 is our most advanced
Oh,
and
they're gonna
integrated
explain
system ever.
Okay, I'm going to explain it anyway. even though I think that's probably the CTO or CEO. So this is the boom architecture. So all your arms are connected to one cart that you push into the patient. And then this is what we're talking about, that Z rail. So you pop your instrument onto it, and then it will push, this whole square will slide in and out of patient. And then there's motor stacks inside of here that will move the tool, which there's no tools shown here right now that are connected. So all this is capital, and then the tools are reusable. This is your tower with different energy modalities to control electrophysical instruments. And then this is your console, and I think that's probably another viewer screen.
It's going to transform surgery for
Way to go, Gary.
surgeons, care teams, and patients.
And by the way, Steve has done like a deep dive on this. If you want to check out, hey, that's my tablet, baby. Come back. That's my phone. God. All right, let's keep rolling. This is so fun.
Well, I've never
It's like I'm looked at the clock. I was like, all right, so we're 20 minutes in, and I haven't even had you listen to clips from Steve. But this context will be super helpful for the whole space we go into.
seen anything like this before. Force feedback is a
Okay, so force feedback's a huge deal. To break this down, there's so many things we could talk about. Oh my god, I've never done a video like this before. So when you have, hi little love. I really don't want to do this way. I'm cutting an apple on my desk. All right. Oh my god, this is so sticky and gross. I would never do this. I love you so much. I'm gonna clean it later, but I want to get this video done while I have a gap with 2 kids not off the school bus yet. Okay, enjoy your apple, little love. Enjoy Gabby's dollhouse. So, with force feedback, this is supposed to be a body, right? If you have a person over here, this is your surgeon, and they're leaning over the patient, and they have a nice tool in their hands. Old school surgery. And that tool is inside the patient's body, and they're interacting with your colon. And they're about to cut it. They will naturally, because they're holding the tool, get force feedback. They'll feel how hard they have to squeeze to put compression on the tissue. They'll feel how much the tissue is pulling back on them as they're moving inside the body. And that is what a lot of surgeons were used to. So there's this evolution of surgery has occurred in like 4 main stages. The first stage was open, where they cut all the way across your abdomen. There's a lot of bleeding, a lot of risk associated with surgery this way. Patients still lived, others died, right? And it was very invasive, and you had a long recovery with a lot of pain because you're cutting through all that muscle wall. And then in the 90s, which I talked with Steve, you get into laparoscopic surgery, where you were able to go in through small ports or small incisions. It was minimally invasive, faster recovery. There were certain challenges associated with it because the surgeon couldn't have their whole hands in there every time touching everything. They had to work through the instruments, and sewing was particularly difficult, or suturing inside the body. And then surgery like 3.0 would be the advent of robotic surgery. This is with Intuitive or Da Vinci. Intuitive or Da Vinci. And this was when you started to have robotically driven laparoscopic instruments, and surgeons were able to have this level of control to do this precise movement and sewing in a way that felt way more natural. It created the feel of open, but through the precision of robotics. You could also eliminate surgeon tremor in their hands. And 4.0 is when we start to get into digital and AI and smart guided procedures, where you're informing the clinicians digitally on things that are occurring and modifying control of these robotic instruments based on tissue sensing and other stuff. So Da Vinci 5, which we were watching the video for, Da Vinci 5 is like spanning this space, right? They're pushing it here because what clinicians have lacked in 3.0 was that tactileness, that force feedback. When they push on something, they could feel that they're pushing on it. In order to accomplish force feedback, you need to have sensors within your motors that can detect load, like how much current the motor is pushing to get to a given location if you're in position control, for instance. And then from there, you could back calculate like how much force that tool is experiencing. But you have to go from the end effector through all the motors, through the arm to calculate it and have it be accurate and responsive is really challenging. But then when the surgeon's using a GUI, you could use motors to push resistance on their hands to simulate force feedback. If you do it well, it's a huge unlock for clinicians. If you do it poorly, it could actually lead to patient harm and other challenges. So that was
First of its kind
your minute on force feedback.
technology. In preclinical trials, we're seeing up to 43%.
This is a huge claim. So because they have force feedback, clinicians aren't putting as much force into the clinical field, which causes less tissue damage. So you're going to have improved patient outcomes.
Less force on tissue. That translates to gentler surgery
Yep.
for patients.
Before we relied on visual cues primarily, but now with feedback, it does give you that extra sort of sense.
It's not something I've seen with any other system. It's something we experience in open and laparoscopic surgery, but not robotic surgery.
We're going to be able to control so many more things from the surgeon console now, which I think is really important.
It's really an immersive experience that gives you
All right, so we're not going to go too deep into this video. I just wanted you to see the boom, and this is kind of the gold standard. there's the end effector. Show me the cool arms. There we go. Yeah, this is that Z rail. So this would be sliding in and out of patient, and then it'd be rotating about a pivot point on the trocar, and your disposable instrument would latch on right here, and there's a motor stack inside of here to control it, and then the trocar would be right there, latched on, and then it's in the patient. Cool. So let's go look at Otava. Actually, you want to look at Hugo? I actually haven't seen a video for Hugo. Hugo, Medtronic. Do they have anything cool to demo?
Are there any
Good,
bats?
Akio.
No. Are there any snakes? No. You sure?
And then we'll get into the definitions. But this is like really good ground framing. That makes sense.
We started with a purpose.
Just show me the robot.
To bring robotic-assisted surgery
Show me the robot.
to more people.
CMR's is better. It's
in
better
more
video.
places than ever before. And to make quality care a possibility for patients around the world.
Robot.
Now, that possibility is at hand.
Okay. So I saw one of these in Japan. Okay, they're moving a little quick now, but they're not too much. So one of the issues with Hugo's architecture, they have an open console, just like CMR. And by the way, like the market is, I don't think it's perfectly split by any means, but there's some people that prefer to be focused and locked in doing surgery in this little hole, like this video game. There are other clinicians that want to be able to interact with their team better and have that sense of presence. So I've sat down and played around with a Hugo at a surgical congress in Japan. I wasn't supposed to play with it. I was working for J&J, but I took my badge off so I could go and see what everyone else was doing. And it's a really interesting system for sure, because you wear glasses as well to get that 3D view, but you could still look across and see what's going on at the table and yell at somebody. So you'll notice a difference in this architecture, that these arms kind of like cantilever out, scissor out, and they have this big boom here. So if we get into physics for a second, because the footprint of these is larger, and I think they're heavier than CMR as well. I don't have the actual measurement. But you basically have this base. I don't know what's going on in here, this big tower thing. I don't know if it's got a whole bunch of software that's running, or if it's just a heavy column. But then your robot kind of scissors out. That's probably too many joints. And then you have your instrument. Did it have a Z rail? Let me check really quick. Yeah, I think it's got an insertion axis.
Meet Hugo.
Yeah. So that tool can slide up and down this rail. It's very similar to Intuitive. So then you have your rail with your instrument that goes through a trocar. Drawing and you're not seeing. I can see my tablet. And that goes through and that slides up and down on the rail. So all of this, if we look at physics for a second, this is a joint with a mass times gravity and a mass times gravity and a mass times gravity. And when you're calculating moments, you want to look at your force, your mass times gravity, times the distance, d. As distance gets longer and the mass gets bigger, you need a moment in the opposite direction to restore it, which means you need to have mass times gravity, and this is a shorter distance. So you need to have more mass on the back end of this cart to handle this mass that's kind of sprawled away. So that's why the footprint of this thing looks bigger than CMR. Man, just chatted with the chief commercial officer. I can't even say the company right. So that's the first thing I noticed is like, what is going on in here and why is it so tall and big? And this is a wider base. I'm actually curious dimensionally how big of a OR footprint this is compared to Intuitive. So all of this clutters the OR. Like I've been in procedures in Japan with really tiny operating rooms, and I don't know how you would fit a Hugo in it. I've seen some with a Da Vinci in it, and it is like wall to wall, just tight. And that leads to the architecture of Otava and their potential value prop. And then we could jump into the thing. Let's go to J&J Otava. And this platform has received approval for FDA IDE first in human clinical trials, and they've done a few procedures. I don't know how many. Let's see if this is going to work. A new era of surgery. Did they change their website? Their video is great at showing absolutely nothing, which is sad because I know all of it. I mean, I worked on this platform for like 8 years. Show me the picture. Where's the cool picture? They normally have an animation here that's not working. J&J Otava. Let's see if I can find some images. They're not going to show me anything. Oh, cool. We can look at patterns. That's smart. And I can't disclose, confirm, nor if it looks like this or not. But this is the concept. You have a table. This was for a prior architecture with a company called Oris we acquired. And then you would have this. Oh my gosh, how to start up. This is a. How did he get this picture? Did he make this picture? Sorry, how to start up in MedTech is Steve Bell. This is the whole video we're watching. Where did he get this picture? Is this part of his secret newsletter he has? First early review and sad concerns. So he's looking at the patterns. Did he draw this? Now he's super concerned. Interesting. But you have a bed with arms underneath it. So the value prop of this is that it has 0 OR footprint besides the surgeon console and a cart. And what this allows you to do is you could do normal procedures in that operating room on a table, just like a normal table, and you could turn into robotics and do a robotics procedure. So it allows you to toggle between different kinds of cases quickly, assuming that you can get the same clinical reach from this 4-armed robot coming up from the table that you can from something coming down from a boom or the cart-based architecture. Additionally, you're going to have J&J instrumentation on it. You have the J&J MedTech brand as well, which is pretty compelling. So this is a different way to position an architecture, but J&J is very closeted about it, so I have to be careful what I know and share. But those are the big players in robotics. You have Medtronic with the Hugo robot. You have J&J with Otava, you have Intuitive, and now you have CMR is potentially being acquired for, I think, 4 billion, or at least that's like one discussion. So let's jump into the podcast now. With that ground knowledge, Light Touch Robotics, let me know in the comments if I missed anything, if you wanted more details on something you saw, if you want to deep dive on these systems. I've worked across J&J's stuff for quite some time, which means I've been proximal to what competitors are doing as well. But the reason they keep showing you pushing the cart around is because it is wild how small of a footprint that is. I am curious though what kind of end effectors you can and can't have on this architecture from a stapler, energy device, things like that. Okay, let's jump into the video now. Groundwork. So all we're going to do is just find little markers. I'll hit play, see what I said, and then we'll chat about it.
As well for your listeners, but also just, in case my mum watches it.
No, it's helpful. Like I love as for something about stapling technology for folks who don't know what a surgical stapler is, like it fires a whole bunch of rows of these really tiny staples and it compresses the tissue and then transects it. So it allows us to cut with minimum bleed.
All right, let's look at one. There we go. So surgical stapling is awesome. We're going to do Ethicon Echelon 4000. So this is not our robotic stapler because I can't discuss that. This is our handheld stapler. So this is honestly one of the highest performing staplers in the market. And when you put this through a trocar, this one is for vascular. So it's for working between the ribs to close lung tissue. That's vascular, means like lung tissue. Do they have a picture of the cartridge? So this cartridge is filled with, these slots are filled with really tiny staples, just like in a normal stapler. It's a U shape. And, shoot, I'm going to draw it. I worked on these a little bit, which is fun. So if we look at a side view, let me see the best way to draw this from the inside. I'll just start sketching on top. We're going to wing it. All right, so you have these little slots, right? I think there's 3 rows. Oh, no, there's 2 rows on the vascular. There's 3 rows on non-vascular staplers that are taking down colon or lung. And you have this big, long slot. All right, so what happens is inside of each of these slots, there are these little staples. And inside here, like underneath, there's a mechanism that will push. Forgot how it works exactly. I think it spins. It'll drive these sleds. So a sled looks kind of like a triangle, but it's got like a side profile. Oh my God. It's like a wedge, okay? And the wedge will scoot forward and it'll pop the staple up. And the staple will go through the tissue. And then on top of here, there's something called an anvil. And the anvil has these little divots carved into it. It's made out of metal. It's really precise manufacturing. And the staples will hit the divot and it'll cause them to curl. And when they curl, if you look at your tissue, you drive your staple through and it curls. And when you do that, you're creating compression on the tissue, which there's a lot of technical artistry in making sure you have enough compression that you don't have blood oozing out, but you want to have some blood flow to heal the wound. And you don't want to be so tight that you just crush and damage the tissue. And when you're working with frail lung tissue or diseased tissue of different thicknesses, there's a lot of challenges in that space to deliver consistent compression. So basically, you're going to drive this wedge. It'll follow the path and it'll staple, 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 staple. And then a mechanical knife will cut down the middle and transect it. And that allows you to cut after compression. That's how stapler works. It's a lot more complicated than that. It takes a large team of really smart people to make staples great. All right, let's see what our next dot is.
Pitching as a startup. If you pitch at a startup and you go through all your stuff and you do a show up and throw up, as I call it, and you end up just talking and you leave that last slide. And the last slide is just like a set of technical details. And you go, and that's the technical details.
Yeah.
It's a really, that's not human. That's not how we work as humans. You don't go to somebody's house, have a nice dinner, finish the dessert, stand up, put your coat on and just walk out. You don't do that. That's not how humans.
Oh my God, this is so good. So I consulted startups in Japan and a lot of folks, let's talk about the innovation trifecta and it'll get to pitching. A lot of folks get hung up with what I call the innovation trifecta for any startup, in which you have an unmet need, like I need a better way to walk my dog. That saves me money. That's an unmet need. Met need. And then you have technical feasibility. Like, is it possible to develop an app that can connect you with a dog walker at the best price possible that you trust? And just like the Uber of walking dogs, right? Technical feasibility. Is it possible to actually make something like that? And the last part that people struggle with is just commercial viability. And it's the idea of, yeah, you made all this, someone needs it, but do they have the capacity to pay for it? And is that capacity to pay at a level that makes it financially viable to run this business? Many founders struggle to triangulate these three things. And because making code is comfortable, say for a dev, they're just going to sit here instead of having conversations with people to understand, did they find a real unmet need, or is it no man's land? Is there a way to sell this product? No man's land. So you can work with people that can progress a technology for multiple years that nobody has asked for or wants, and nobody has the capacity to pay for it. And a medical device, there's even higher risks associated with that because the development cost is just so incredibly high, and the barrier to entry is so hard. So what we talk about with Steve, because he's the chief commercial officer, is learning how to position products and develop technologies driven from that commercial need and from that unmet need. The other piece that I add to the innovation trifecta is this idea of branding. Branding is really storytelling, and it welcomes people into the story of what you're trying to create and why it has value for them, and it starts to create a perception of quality. So for instance, the Johnson & Johnson brand is incredibly powerful. When you connect that with a robotic platform that does have a lower OR footprint and still can deliver at the same level clinically as a competitor like Intuitive, which is debatable, people will convert possibly just based on the brand strength that they've been using Ethicon staplers or energy products for so long that they want to trust and believe in this robot as an alternative to Intuitive. So branding also helps you build a business. This innovation trifecta is like my working model for creating anything or starting anything. But when he goes to this idea of like startup folks like ending their pitch on technical details and just like showing up and throwing up, like they drop their info and leave, he starts to go into some really beautiful stories around how important it is to actually leave the table with a relationship. How does this conversation lead to the next conversation, the next handshake, as opposed to just dropping data and walking out? So you wouldn't go to someone's house and eat a meal and be like, thanks, and leave, right? There's always a kind of a follow-up. So this kind of bridged into that. I think this whole video is going to be lingering thoughts with some definitions. All right, let's keep rolling. We got a lot of markers. And let me know which one ends up being your favorite.
The alignment back again. And I don't want anyone, especially if you've got younger people starting in their career watching this, I don't want them to think it's all, rainbows and unicorns and it's all happy in meetings and stuff. I mean, sometimes there's almost like close to punch-ups in meetings.
Oh, man. I think I just flagged this one because it's so good. A lot of my work at Johnson & Johnson as a systems engineer and eventually as directing front innovation was just working between competing factions. I often called it Lord of the Flies within industry. You have marketing, you have quality, you have design engineering, you have production manufacturing. There's all these different competing groups. And I call it Lord of the Flies because you're supposed to connect and collaborate in order to solve problems and serve patients. But you also have ego. You have people trying to get the next performance rating. You have people trying to protect their own budget so they're not helpful. You have bandwidth constraints. Learning how to escalate and navigate alignment conversations is so critical in your career. And it's really the engineers that learn how to talk that do well, like that learn how to work across all that nuance and have great ideas that they create. That's how you get stuff done. So I love the ambiguous problem spaces and the volatile politics because you have to work through that to actually move anything forward. And you can't do this on your own. So partnership is necessary to progress global innovation. All right, that's my lingering tidbit there. Let's see what the next one is.
Yeah, because we've talked about this. Like I worked as the 16th engineer in the whole Verb Ethicon experiment. So I was.
Okay, so what is that? There's a beautiful diagram that shows what I worked in. Ethicon, Verb, J&J, Google. It's a beautiful image that is incredibly complex to understand. There we go. This is from so long ago, 2018 when we started. So I want to draw on it. Shoot, let me get my tablet. We're just going to redraw what I pulled up. So the way it worked, you have, it's funny because it kind of feels like a robot. We're going to go into business partnerships, okay? It's going to get complicated. There's supposed to be a hand here shaking. So I worked at a company called Ethicon. Oh my God. Ethicon. This is all completely improvised, by the way. I have no plan. Ethicon was a company owned by Johnson & Johnson. Johnson & Johnson has tons of operating companies. They have DePuy Synthes, which makes orthopedic implants for knees and your head. They have Cerenovus that does work with stroke, mitigating strokes. There's lots of companies, and Ethicon at one point was kind of the crown jewel of J&J. They make minimally invasive surgical staplers like we walked through. They make energy devices, which are bomb. I worked on their harmonic technology. We don't have time for harmonic right now. It's like a vibrating stick that cuts and seals, and it's awesome. I spent a lot of time on it. And they had all these different instruments that were great for open surgery, surgery 1.0, laparoscopic surgery 2.0, and no robot. And every year they were losing market share to Intuitive that was starting to build out the robotic surgical market. And they're like, well, what do we do? Do we make a robot on our own? We don't really know how to make a robot. So they shook hands with, you have Google, owns this company called Verily Life Sciences. It's going to get more complicated. There's more hands. And they co-created this company. I don't even know if I could draw it right. Called Verb Surgical. We're going to get into some history, friends. I was the 16th engineer in this group having interactions with this group. The deal was that Ethicon would make the instruments, and then they would get all the revenue from that. And then Verb would make the robot and get all the revenue from that. This is a huge oversimplification, okay? Revenue from that. And that they would meet at the interface. And this is something called a build to buy model, which is becoming very common in medtech. We'll get into this with Steve a couple times. What a build to buy model is, all right, we're going to break this down a lot. So Johnson & Johnson is a publicly held company, which means that they have to deliver results to shareholders every quarter. They give dividends, and they have to show consistent financial improvement of the business. Because of that, they're driven heavily by something called a P&L, which is your profits and loss. It costs this much money of R&D research to develop a product. It costs this much to pay your sales team to sell it. It costs this much to manufacture it. That's all losses. And the profit is, but we sold this much revenue, and this is the difference between those two. That's your profit, right? You have your top line, bottom line. I'm not going to go into that too much. But the reason this is important, for profit and loss, if J&J just started a huge R&D organization focused on surgical robotics, it would be incredibly expensive, and it would hurt the P&L. So there's always a pressure to shrink your R&D costs, even though you're reinvesting in the business. But if you start a company and have it co-funded by a large player like Google, then it's called a build to buy, in which you at the front, so at the start. Now, this was a crazy build to buy because you had two monsters shaking hands. This isn't normal. So at the start, you have some agreed terms of we'll give X amount of money, and then this is me trying to be a lawyer for a second, you give robot by TBD, to be determined date. and then and we buy you for secret number. There's so much I can't share. So anyway, you enter this agreement, and what's cool about this is that if the investment number is low enough and you get other investors like Google or other folks at the table to invest in this venture, then it gets it off your P&L short term. And there's a lot of advantages to that. And you have all this expertise coming in from Verily Life Sciences to get the platform going. On paper, this all looks great. There was a ton of legal issues and IP firewalls between these two groups that I was a part of escalations with that prevented us from collaborating. And additionally, you often want to do a build to buy where you're not collaborating, where you lay out, this is what you need to develop, this is what we'll develop, and then we'll commercialize it. And then you meet at an interface. But it got really messy and we started flowing ideas into both sides. And then another partner showed up. Here's a shiny hand over here. We'll put some shine on it, called Oris. And this was founded by a guy named Fred Mall, who was ex-Intuitive. And by golly, they had a beautiful robot that could do everything that we were trying to do with Verb, by golly. And they had another robot on the market that did endoluminal robotics, where you could go through natural orifice like the lungs in order to do biopsies. That was already being commercialized, even though they had profitability challenges with that, because the tools aren't reusable, so they're expensive and a loss. And J&J was like, you know what would be great? Let's just stop development. Let's give this a big old stop sign. This is all the history you need over 8 years. Let's stop Verb, even though we were like bored. I don't know what we declared externally, so I have to be careful. We had progressed instruments in the system very far. I will say, I can't say because I don't know what I'm allowed to say here. We had made a lot of progress and a lot of people had worked very hard for a long time. And then J&J was like, swoop did a dupe. Let's just buy Oris and move all of our Ethicon people onto supporting Oris. And let's let Verb kind of be this side backup. And let's go all in on that for a year and a half or so. And then he's safe. And then all of a sudden, Oris doesn't. Do you see how complicated this is getting? Oris has problems for undisclosed reasons I can't share from an architecture perspective. I'm smiling because it's pain. And then 1 minute, let's go back to this architecture, but pull in a little bit of this piece, and then let's launch that. I'm going to go check on the baby. Give me 1 second. I can pause this, I think. No, I can't pause it. I'm just going to let it run and pick him up. Oh my gosh. He's good. He's just grumpy. He might need a little bit of a fruit bar. I got you. Daddy's got snacks. I hope this is both educational and entertaining. So anyway, swoopity boop, we buy Oris. Then we buy Verb Surgical. Or we might have bought Verb first. I forgot which one we acquire. So now we own all 3 of these companies with 2 different table-mounted robotic architectures. Decisions were made to pivot back to this architecture with, I don't know what I can share, pieces of Oris, bringing all of it together. And now hopefully we're going to launch something someday. We're doing clinical trials right now. This was like multi-billion-dollar experiments. Okay, Oris, I forgot the exact amount, was maybe 5 billion, 4 billion for the acquisition. Verb, the partnership and the acquisition wasn't fully disclosed from what I understand. It's too many billions. J&J's hurting because they can't get a robot out. But the architecture, it's clinically viable in my opinion. So we'll see. So anyway, this is a whole mess of context. So when I say Ethicon and Verb, that's what it means. I was the 16th person on this. I've worked across every robotic architecture that J&J has tried with this partner and this partner over the last 10 years. And I've seen all of the leadership come and go and the vision shift over and over again because of it and the pain. So if I were to start a robotics company, there's a lot of things I know that I wouldn't do. All right, let's see what the next clip has for us. Again, let's keep rolling.
The data can often be the source of truth and the ground truth. So sometimes what you have to do is you have to take the emotion out of everything, because it's somebody's pet baby, it's somebody's real pet idea. They've furnished it for a long time, and they're
okay. So going back to this, there were so many. I can't even draw them. There are so many cute little babies. This is little monster baby, right? There's Ethicon babies. Like, we need to have this surgical instrument because we have it in handheld. It has to be on the robot. But do robotic surgeons want this instrument? No, but Ethicon's ego says yes, so we're going to keep going. That's a baby that needed to get killed. It was killed and restarted multiple times. I can't disclose that baby. Full software architectures that didn't make sense, different interfaces that didn't make sense. There were so many burn the boats moments we had, and I don't have time to unpack what burn the boats means. Whenever you're developing technology, it's not just getting that little trifecta perfect. You also have to deal with like human ego. Like, there are conversations that this acquisition, there are certain people that wanted to see it done regardless of doing the right due diligence on if this made sense from a business perspective, even though your numbers are in the billions of this acquisition. Stuff like this happens in business because people get locked onto something they want to be seen doing. And it's dangerous. Cool. Let's keep going. Ego's great. What we got next?
And if you're at an impasse, you quite often have to make a tie break and say, okay, guys, heard it all, love it all. Based on the data, based on really good arguments from both sides, I think the best way forward is this.
We did not have that within Verb in the early days. You had one company, Verb was trying to progress the technology in order to get acquired, and you are working in a startup culture. And then all the Ethicon partners are putting roadblocks and constraints on it because we're also saying, like, hey, you have to launch this robot globally, and we have our quality process and all these other boxes you have to check. Like, we're not a startup, we're a huge heavy hitter. And the problem is neither company at times have the authority to tell the other company what to do. And that's why I think political gridlock killed this platform more than anything. I spent months of churn on requirement, definition, alignment, and structure because I couldn't get a decision at the right level, and Ethicon couldn't tell Verb what to do, and Verb couldn't tell Ethicon what to do. So what Steve's getting at is, like, it was at times an impossibility based on how the agreement was structured and how executive leadership was shaking hands in some really messy ways. We put roadblocks in front of each other at times to protect our own base business and future business from different IP litigations and things that could happen. Very complex cluster to navigate, if that makes sense. All right, next one. But fun.
We navigated so many unknowns.
Okay, we don't need to go into that because I just answered that one. Hi, buddy. Thanks.
But there's this big cultural mismatch because I think, at least for us engineers navigating college, we want to create and build, and then we enter a large corporate like that has the cash flow, but not necessarily the appetite for those risks.
This was something that took me many, many years to learn with Johnson & Johnson. And it's something I still struggle to accept, but I've seen multiple layoffs as a product of it. Because of all the pressure, ankle, little trout. Because of all the pressure, from a P&L perspective, you're often, these large strategics at Johnson often innovate. I was just checking the audio levels to make sure I'm good. Yeah, often innovate by acquiring a company. Ew, that one's chewed on. By acquiring a company that has already cleared the FDA, and then they just commercialize the heck out of it. But it drives the engineers crazy because we got great ideas under our desk that we've been working on. When we look at what we've been doing and what we could do. Remember one front end project I worked on that I can't share was really cool. And we were in the make or buy discussions. And I just didn't understand early in my career that we weren't going to make this technology, even though we could do it better, because we could buy something that was close to the right thing and then just scale and tweak it iteratively. And it drives me crazy. But when you have a lot of folks that want to innovate that way in a culture that doesn't encourage it and lays people off, you receive these mismatched messages with your context. Let's find the next one. Oh my god. Fuck you.
Don't worry about your kids, by the way. Let them go. Just let them go.
Yeah, you think that's funny, don't you? It's so timely. All right, well, I'm just gonna let them go. We're gonna let it rage. I actually wish we had more time during this discussion to talk about integrating fatherhood and entrepreneurship. Probably one of our next tracks, most likely.
Square. Let them talk a little bit about the history and the mystery. Let them talk square. Let them around, right? You know, why was the wheel round and not square? Let them talk a little bit about the history and the mystery. Let them talk a little bit about the why and where they got to, and why did the wheel end up this thin, this thick, this heavy, this whatever in the past.
This is a deceptively simple lesson from Steve that I don't want you to miss. It is so easy for us to have this framework of like, it wasn't made here, so we have to make it here. We have to innovate it ourselves. And Steve is a huge proponent of you need to go external. You need to connect with subject matter experts, the folks that have done this before, because they're the ones that know why the wheel is this thick or this round, why it doesn't have pointy edges. And he goes through some beautiful case studies in the podcast as well around it. But I would just double down on this insight. It is so important to find folks who have gone before you. I mean, this is why I love coaching in my community as well. As like, I'm running into people that are about to make all the same mistakes I've made in my journey, trying to build a global life with my family. So many entrepreneurs that are doing the same things wrong that I did a year ago. And in industry and in startups, we have to also have the same mentality of how do we just find people that know what not to repeat. So good. This whole section was really good.
That's what saved people in business more than anything. Making mistakes is absolutely great. Repeating your own mistakes is a bit stupid. But repeating mistakes that have been well documented for the last 15 years is just unacceptable.
I've listened to this conversation more times than you could possibly imagine in the editing process. Oh, fine. And that one-liner is like the biggest takeaway from this whole conversation for how I start my next venture. Like if I'm in interviews right now for the director of front end role, which would be awesome. Like I want to understand what mistakes have we made from trying to figure it out, you know, making the same mistakes. Like how do we not make the same mistakes as an organization? But also like how do we not make mistakes that have been well documented for the last 15 years? It needs to be on a t-shirt, honestly. It is such a good one-liner. All right, let's keep rolling. You trying to share your graham cracker?
Their best every day. But sometimes experience beats intelligence.
Well,
quite often. Scissors is a great example. You know, I could go on for a long time about scissors, but getting a pair of Metz and Baum scissors to
yeah, it's not Metz and Baum scissors. I actually don't know the exact name, but we're gonna look it up. Let me slide my tablet to the side. Da Vinci surgical scissors. Metz and Baum. I don't know how to spell that. Let's look up some scissors really quick. Oh my god, so beautiful. Oh, All right. Show me a scissors. Ooh, single side. That's so fun. There you go. So, I don't know if I can make that bigger. Vision, energy devices. Oh man, I want to go so deep in all this, but I gotta stick with the top. Right. Is this not the strangest YouTube video you've ever seen? We're gonna go with this one. So basically, what Steve talks about is, buddy, just he's so determined. Okay. If you look at a pair of scissors, I'm going to show you what you imagine versus what's reality. It's going to blow your mind. Prepare to nerd out. Buddy, we're doing it live. All right. So, what you imagine is that these scissors just do this. Slice, slice, slice. Well, there's actually a force going like in plane or out of plane. These scissors, in order to slice, they not only have to touch, they have to provide a spring force into each other. They push as they slide. I want to re-stress that. When you use a good pair of scissors, not the crappy ones, they're designed in such a way where the two tips, the pointy parts, they're actually designed to, at that edge of cutting, press into each other so that there's a force. So if we looked at it kind of sideways, how the heck can I show this? So we have a pivot point. Let's say it's a pin. All right. And we're going to have our top blade. Am I even going to be able to draw this the right way? We have our bottom blade. I can't even draw it. My brain can't fathom this. Like this top blade is set up so that at this cross point, it's pushing into the bottom blade. The bottom blade's pushing up, the top blade's pushing down. Like, it's not that they slide past each other, they cut into each other. And what Steve was talking about here is to get that leaf spring force perfect across the tolerances of this fit, the dimension of the blade, multiple uses is also a challenge with this, cable tension, like getting a scissor to cut consistently without going dull in a surgical application is incredibly challenging. I can't even unlock the mystery. I worked adjacent to this team. Okay. If I were starting a robotic surgical company that needed surgical scissors, I would call somebody that has done it. I would not attempt to do it solo because there's so many theoretical and applied physics things you need to navigate to actually get this locked in and functional. It's not as simple as it looks. Come on, man. I love you. I want to say, could you be somewhere else? But you're right where you need to be. All right, let's keep going. Out of my mouth, though, okay?
And you go in there and you look through your catalog and you select your material because you look at the properties of the material and you decide that it's going to be this kind of braid, and you're going to decide it's going to be this material, it's going to be stainless steel because it's going to be this kind of stainless steel because it's quite flexible and malleable, but it's strong, but it's okay from a cost point of view. If you'd have gone and talked to the cable expert who's done nothing but 65 years of cables through pulleys way smaller than that and the stress is way higher than that, they would say, oh, no, you can't use a stainless steel cable on that. Oh, no, you can't use that kind of braid on it because that thing will just start fraying and it'll snap and it'll only get you to 3 lives. And you don't have time to be learning the errors. Go and search out.
We spend a lot of time learning the errors. I will say I can't remember. I think the team ended up working with a supplier on it. But there's a lot of dev engineers trying to figure out how the heck do we do cables? What size? It's like a paper cut with a... I'm so happy about it. Anyway, I just want to say Steve's right. Maybe that's the lesson from this part. And there's a lot we probably shouldn't have done ourselves early on. We did tons of cable testing, material, figuring out how much it was braided, testing things at end life endlessly until they broke. We kind of had a build stuff, break stuff mentality, which is good in a startup. But as he was saying, there's people that are phenomenal at this, and we should just found those people. I think we acquired them over time or built the right partnerships. Definitely in the early days, it was like, just throw some engineers at it and see how quickly we could build and fail. Maybe not the right use of resources.
Sometimes big and legacy can help you in certain things. If you're doing supplier negotiations, or you're talking with contract manufacturers, or you've got a list, a Rolodex, it can help you. It can help you a lot. But in equal spades, it can really stop you as well, because you try and force everything into your square box of the legacy.
Yes. Okay. What's the box? I know. Buddy, this is a good video. We're going on an hour and 10 minutes of deep dive here. So what's the box? So the box is what an existing opco like Ethicon, I'm getting so much love, has in it. So you have stapling, clip, we'll call it ligating, which is like clip appliers. You have energy. Oh my god. Harmonic, which is vibration. You have end seal, which is running RF electricity through two panes. I don't have time to break that one down for you right now. Do you need another one? I feel like... Are you not entertained? What? Oh, you want the other thing. I didn't think this was going to be a snack and share, but it's a lunch and learn. Okay. Anyway, you have this box. This is what almost killed my assignment in Japan. Here you go. I hope that makes you happy. You want that one too? All right, you go enjoy that, and you come back when you're done. I'll give you more. Go have fun. Yep, go play. Go find something fun to play with. Yeah, go have fun. Oh my gosh, she's so cheeky. All right. When I went out to Japan, let me draw my little Hokkaido island, and here's a nice version of Japan. There's Okinawa down there. Joe went from US. They flew me to Japan, and they said, we want you to go and find opportunities in the Japanese market and bring it back to the US. And I was told to have a blue sky vision. But I also have people in the business tell me, hey, if it's not in the box, everything you're working on is going to fail. So I was like, am I directing front-end innovation? Like, am I finding opportunities, business dev opportunities here? Or am I not? If it doesn't fit in this world, there's no way we're going to pursue it, develop it, acquire it. So there's this really weird tension you create. Because if you stay in the box, all you get is iterative. You find a way to make your scissors a little sharper. You find a way to make your stapler bend a little bit more. And then you're always selling slightly improved clinical outcome at a premium cost. And eventually you kind of approach this asymptotic growth. And then if you're in this box of innovation, you can't do anything. But what Steve starts to talk to later is there are certain times when a business also needs to have another working group outside the box that are trying to destroy this one. They're trying to kill it. This is fun, right? So their goal is to figure out what would destroy the base business of Ethicon, and let's develop that. Let's test it. Let's get our little beaker over here, and we'll make something awesome. And then we'll either acquire a company that does it, or we'll just pass and wait for the hands of time to kill us. And one of these groups that's really big is, I said it wrong in the podcast, is interventional oncology. And I'm going to explain what this is and where it came from. It came from something called LCI, and then I'll define what these words mean. LCI was the Lung Cancer Initiative, and the goal was to look just at the space of lung cancer and figure out, I'm going to draw up here. I'm going to draw over here and get back to the box. So you have Ethicon's box, for instance, was what we call intraoperative. So this is like you found cancer and now we're going to cut it out. We're going to use staplers, clip appliers, every device in the box. Eventually, we're going to do it robotically. It's a new box we're trying to get into, but it's still intraoperative. What Lung Cancer Initiative was asking is like, what if we intercepted during what we call before intraoperative, you have detection. Say early. They started asking crazy questions like, what if you could go in through a natural lumen through a lumen is like a hole, like through your esophagus. Is that the right? Yeah, down the throat into the esophagus, into the lungs, into the bronchus. And you could look in the small airways and you could do like biopsies. Or maybe you could do something with pharmaceutical assets, like locally inject something that helps prevent cancer. Early detection. This is outside the box. And the problem is the way that this company is funded from a P&L perspective, it's difficult for them to pursue an early detection opportunity that would then kill their P&L. It's hard for them to break their own business. So you had an entirely different group, the Lung Cancer Initiative, funded a different way within Johnson & Johnson to look at these opportunities, and it did lead to the acquisition of Auris. Was a major output of that, of what if we could do early detection and have a robot in that space. Eventually, this evolved into interventional oncology. Oncology just means the study of cancer, I believe. Interventional means intervening in cancer, and we're going to add the note of earlier. So trying to get outside of Ethicon's box and work it backwards. One of the big blessings and issues with this workflow is that you want to have partnership with Ethicon, but it's difficult to actually collaborate because anything that's coming from this group is destroying this business. It's killing it, but it's necessary for the holistic business to work. Later in this talk, Steve Bell talks about like 30% of amputative surgeries. Amputative is when you amputate out or cut out a part of the body, are going to decrease. And we've already seen that through Ozempic with a lot of procedures for like gastric bypass, which would shrink your stomach, I believe, so that you would be less hungry. Like those cases have decreased dramatically. That used to be a huge for Ethicon's stapler business. Our stapling business was built off of gastric in many ways. So this is a challenge, but if J&J doesn't do it through LCI or interventional oncology, startups are going to do it and beat you anyway, and then you just try to throw your weight around because you have scale and commercial strength. So that's a large unpack. And it's challenging to continue to innovate outside the box because the box wants to constrain you. And I ran into issues in my role of like, who's paying me? Is it J&J MedTech? Is it Ethicon? Where should I be innovating? How do I complete this mission? Like I'm always working on alignment to figure out what are the problems we're actually trying to solve. Who are we trying to cure? What disease states? What stage? And who has the appetite to navigate the risks of developing solutions in those spaces? All right, let's keep. Oh, you want more of that? Okay, I'll get it for you. Let me get you some. Stay right there. I'm going to trick him. I'm going to think that he has to stand up to me. Yeah, it's coming. Here's your fig bar, buddy. Here you go. Oh, you just wanted one. Beautiful. All right, what's the next one?
Anyone who's been and done this a lot understands that the architecture behind the teams is crucial.
Okay, I'm not going to pack this one as much. I'm just gonna say this was a something show. All right, and it wasn't thought out because we're building a plane while we're flying it, while we're figuring out who the crew chief is, and if we check to see if there's gas in the plane. That was the leadership vibe that it felt like when I was 16, and we were scaling aggressively on both sides. Order of operations was out of order in many ways. And the dynamics of how we communicated was also poorly manufactured or architectured in the beginning stages. I'd be curious to see where this business unit is now because I've been out of it for about 2.5 years. But I do know in the early stages of all these handshakes, it was really, really messy. And I think that's one of the main reasons we didn't enter the market. It was people and really organizational dynamics versus the technology itself. All this should have been technically feasible and delivered much, much sooner. Let's keep rolling.
If you're in a company, you should have teams that are trying to destroy your business. I think they should be trying to out-innovate your business. So
like outside of front end. So you're basically taking some folks and figure out how to compete against your own core business unit.
Yeah.
Oh, I love that.
Okay, so this again was everything that we shared already. I realized on that last one I didn't show you. This is the show, okay? The something show is here. And then going back to that box, it's groups doing this is what he's talking about. And I love it. The problem which we get into is if you're directed front end, can you allocate headcount to breaking the business versus finding something iterative that has what's called an ENPV. This is your estimated net present value. I actually calculated one of these in another YouTube video. You're basically looking at if I'm investing so much money right now and it takes X amount of time to get to commercialization, and I think the cash flow from that commercialization will be this amount, you can calculate what is the present value of working on this right now versus another opportunity. Because another opportunity, you might be able to get to the same amount of cash flow faster. You might be able to get to a larger amount of cash flow later. There's ways to calculate whether you should or should not be prioritizing different activities within R&D. And the problem is for this, what he's talking about here of having this group is that group creating enough EMPV versus someone who could show me I can get this thing launched in 2.5 years if I add this extra angle of articulation and we commercialize it and sell it a little bit more. This is what keeps you stuck in the incremental, is chasing the EMPV short term and playing the speed game versus the long-term strategic vision and technology implementation. This is why certain companies like J&J struggle with launching new platforms, because you have to get all the pieces together in harmony and keep the business prioritizing it without killing. I love that Skool. All right, let's keep rolling. I think I'm going to have to wrap some of these a little quicker. Okay, we're getting close.
Ablation, atrial fibrillation ablation.
Mm-hmm.
You know, everyone was working on the kind of you were doing.
Okay, atrial fibrillation ablation. What that means is you enter the body through with a catheter. Should I pull this one up really quick? You can pull it up. BioSense Webster. So this is a Johnson & Johnson company, but there's other competitors in this space. And let me see if they have a cool video. So you go in with a catheter. Let's see if I could find anything fun. Show me. So there you go. And this thing can ablate. So what that means is it creates like a field of electricity, energy. I actually am not an expert in this, so just ignore everything I'm saying. But based on these different tips, you would put a pattern on the heart to get it to beat differently. And there's certain therapeutic benefits of this to help with your heart rhythm by actually putting some scar tissue on it. Not an expert in cardio, but that's a very light touch walkthrough. I want to be an expert. Give me some time, right?
Thinking. That's a leader who's really trying to understand.
Okay, so this would be innovation oncology then.
Okay, interventional oncology, Joe. You're wrong. I lost my words.
Otherwise, but a lot of surgery today is performed, which is amputative surgery. You basically take big lumps of your body out. So that's going to be replaced in the next 30 years by either earlier treatments that mean that you don't get the full bowel cancer, so you don't need your whole bowel out.
Yeah, I'll let him keep going. This is where we started. If like, did you understand all this?
You just have a small thing like in what they call an ESD or an endoscopic submucosal dissection. You have it done with an endoscope inside your bowel rather than chopping your whole bowel out.
Okay, I can share that. So Let's provide some context. And then maybe that's as deep as we go on second sips because we're pushing an hour and a half and I got to get my kids off the bus soon. I'd like to get this edited out. So if we're looking at your body, okay, we're going to, my medical drawings, this is a butt, okay? And there's some arms and a head up here. So you eat food through your mouth and then it goes through your esophagus and then it goes into your stomach. I'm gonna mess all this up. And then it goes, I think, into your large intestines first, which are this winding lazy river, and then small intestines. Someone's like, "You're already wrong." I don't know. Okay. And then you have a colon, and then the colon connects to your anus, and that's how you poop. That's where poop comes from. All right. So if we zoom in on this section, you're like, I'm not ready for this. Hey, it's medical. We keep people alive, man. All right. So you have the butt, right? There's a hole and there is a colon. What he was explaining is with amputative surgery, what we normally do is come in through ports over here and here and here and here. I've seen a lot of colorectal procedures. And you're going to do something with a linear stapler. So you're going to cut across the colon. So you're going to get your staple lines, and cut. And then you're going to get your staple lines, and cut. And you're going to lose a huge part of your colon. And there's different health challenges post-operative associated with this. But not dying of cancer is a good thing. Because maybe there was like a polyp or something bad there, right? And then you have to bring these tubes together. So how do you do that? Well, we have another magic stapler. I'll show you a picture of it shortly. You okay, love? I'm going to do my best. I'm not a surgeon. Okay. Little love. Oh, Akio, don't pull on her hair, love. Emiko, just scooch away from him a little bit. You're faster than him because you're a big girl. So this is the remaining good part of the upper colon. This is the lower colon. And we're going to enter transanally with something called a surgical stapler. She's okay, by the way. Is she okay? Oh, he's stuck in her. 1 second. You can't pull her hair. I'm going to fold it up so you see. Okay? Once we have this dollhouse. You still want to. Yeah, I'll put you here first so that you're away from him. That way you can't have your hair, but you can still see it. Okay? Akio, you have to be gentle. Gentle. I'm gonna give her a graham cracker. Here, love. Let me go. This will help. Just munch on that. Here, munch on that. All right. Y'all are like, I'm ready for colon cancer. No one's ready for colon cancer, but it comes. It runs in my family, so I care about this stuff. So basically, you have a device called a circular stapler. All right. It's got a handle, trigger. This is our powered one. Its code name was Vegas. And basically, you're going to have something where it stabs through. This is a little bit too long, but it'll stab a hole through this stapled sealed section and this section. And then there's something you put inside of here called an anvil, just like with the straight staplers. And it connects right there. And then it'll squeeze and squeeze. And then it'll punch out a circle hole. And it'll connect the tubes. And this is amputative surgery for colorectal resection. Oh my God, Netflix died. We're done. We are so done if I can't turn this on right away. There's no way I can hold their attention beyond that. All right, we're back. So basically, this would end up resecting out the whole section of the colon. Let me show you a circular stapler really quick for context, and then we'll get to what Steve's talking about. Ethicon powered circular stapler. I worked on the manual ones when I was in life cycle, and then I worked alongside the team that was developing it. Oh, here we go. How to use a circular stapler. You all ready to learn?
It is available in 4
Okay, so
to the diameter.
stop talking. Go back to the, dang it. So there's different diameters just based on the size of the hole that you want to punch and what area of the anatomy you're in. And then these little pockets hold staples just like the straight ones do. This is the anvil, and it connects right over here. There's this cool latching mechanism, and then you can kind of pull this section down, and then it'll squeeze the tissue. And then there's a circular knife, and I did tons of knife sharpness testing when I was a co-op actually at Johnson & Johnson to make sure that we could punch through that hole. And there's also hidden inside this anvil a plastic wafer that provides like a cutting board. And when you punch through it, it'll crack the wafer, and that gave clinicians tactile feedback that it was a successful transection. This is a super high risk part of the procedure. Like you can have sepsis if this doesn't like work correctly. I think sepsis is the right consequence. Like you have the bowel, like you need it closed because crap's going through there, right? Let's see if this shows how it works. So that's just looking at your indication. Okay, so you're going to load that in. You're going to suture it around to connect it. And that looks like the anus. So you come in through there. It's the bottom of the colon. And that part was stapled shut. See that? So you're going to punch through it. They're going to adjust the settings so that drives that anvil through. I drew good pictures. This is pretty good. And that's the indicator, the visual indicator, so you know you're in good shape. Then inside the body, they're using a robotic tool to kind of connect these together. And there's the anvil inside the other piece. And then they'll retract the tissue down. And on the manual ones, you like actually spin it down. And they have to adjust the knob. But I've seen this instrument dropped on the floor and reinserted when things haven't gone wrong. Like there's all kinds of challenges in surgery. So they're pulling it in tight till they get to the right location. They're kind of making sure that the extra tissue's out of the way so it doesn't get bunched up. You want your staple form in the green zone so it's the right level of compression. That's over compressed, that's too loose, for instance. And the clinician may keep it somewhere on the edge of that based on what they feel. You're going to compress the tissue nice and slow because you want to create time for all the fluid to leak out so you get a good form. That's why they're trying to cue the surgeon to take their time with it. Oh, so they're showing this is how slow you should be rotating it. Nice and easy. If you're doing this step in a hurry, there's higher risks associated with it. And then they want you to dwell for 15 seconds, like literally stand there and wait, which is something we instruct clinicians to do for better clinical outcomes. And it's still difficult to get them to wait. And then from here, show me the magic. All right, so you do your turns. And now they're going to press the button probably. All right, they're doing some kind of assessment to make sure it's in there real good, I guess. I don't know what that step's about. Oh, and then they retract out. But they punched the hole. Okay. Let's see. So what Steve was talking about, though, is that eventually, let me go back to my page. We can imagine a future where we don't have to cut all of that out. But rather, if we entered robotically and there's some issue here, and we enter transanally with a smaller robot that can do stuff, spray stuff, cut stuff, electrocute stuff, perhaps you could treat this but still allow someone to keep their whole colon. This is a reduction in amputative surgery, but this impacts the sales of something like this. And again, that's why the business gets stuck in boxes, even though this would actually be a better outcome for the patient, potentially, as you develop that tech. So that's the tension you're always navigating. That's where startups are so important in this ecosystem. All right, let's see what else we got.
Come thick and fast with a lot of metabolic therapies. It's going to come.
Metabolic therapies are drugs that change your metabolism. So they change the rate at which you burn food or how you desire food. That's why Ozempic has been huge. I'm not an expert in Ozempic. I have a father-in-law who's leveraging it, and he's lost an incredible amount of weight. I don't use Ozempic. I have different regulations with how I eat. But for a lot of people, it's life changing. And again, I'm not a doctor or an expert in those spaces, so get the help you need. But he's saying that's going to impact those kinds of procedures, because why would you get surgery to constrict the size of your stomach when you could take a pill that will change the way you're eating so that you lose weight and get in a healthier range?
If you spend your life just looking inside your surgical box, and the answer is a better stapler, a better scalpel, a better whatever, you're going to miss the large change. And a lot of people would have heard of Ozempic and GLP-1 drugs. A lot of bariatric surgery has either gone away or been delayed. Some of it's delayed, but a lot of bariatric surgery has gone away. That wasn't making a better bariatric stapler. There's going to be pills that are going to replace a lot of surgery in the future, and surgery is going to decline by 30%.
That is such a banger line. Like, he just dropped that. Like, surgery is going to go down by 30%. That is massive impact on R&D and this whole entire industry. There's different risks with pharmaceutical development and lead times as well. So I don't know where he gets that exact number, but to imagine a world with 30% less surgery is very curious. So I'll hang on that. Let's see if we can squeeze these last ones in.
That product.
Yeah.
So I love uncovering stories of how different innovation and surgery was versus where it.
Okay, we're gonna skip that one.
So what I saw was this change where surgeons were also learning. Right, there was this amazing vulnerability, because before I'd gone in there, I imagined that surgeons were like all powerful gods who just, had this life-saving ability, and how could they have doubts or.
Okay, this is such a huge insight. In the early 90s, when laparoscopic surgery was being invented and put into practice and scaled, our sales reps were able to actually be in the OR. They were trained and were firing and sewing. Like, they were doing procedures with surgeons, which now is kind of illegal for different risks associated with that. And but at the same time, like, I have been in cases with Japanese sales reps that the surgeon is not just like this god doing the procedure. Like, he's looking up at the sales rep, and the sales rep's like, you should use this cartridge for this part of tissue based on this size. Or he's taking a stapler and showing the clinician, this is how you tap it on the table to get the cartridge out without damaging the instrument. Like, he's providing clinical support, and then also sells later, which Steve has some really strong thoughts on that in another video, which is fantastic that he's done. So it is important to understand that even though they go to school for this long and they go through residency and they're practicing surgeries every day, getting better, there are still areas where new technology entering their clinical workflow has inherent risks and challenges that they have to overcome in order to leverage that new technology and integrate it with their procedure. And everyone comes up that curve. And this is why, like, digital solutions in surgery is so compelling and interesting, because if you could bring people up that learning curve faster to digital surgery 4.0, that's amazing. But you need hardware in the field in order to have digital added to it on top of it. That's why J&J needs a robot, so that we could then do even greater things with it, is the vision. Oh my gosh, it's so good. Let's see what else we got.
It's better. And understanding that when you bring that connection, that you bring something to the party, you bring something to the level, you can talk with them at eye level, and you get their respect. That is a really critical point.
Mm-hmm. I can speak to this. Like, I worked in engineering for 8+ years before moving out into the field and attending surgeries and sitting across the table from Japanese clinicians and doing interviews and asking them, like, where's your pain points? What devices are you using? What do you like? What you don't like? Where do you want to see technology move forward? Broaching that conversation in broken Japanese to build trust at first, and then using the translator as well. Like, just remarkable, beautiful moments. To sit eye level with someone that experienced and that passionate, but also someone that vulnerable. When they don't have the right technology, they're limited from providing the care that they desire to give. And it's been so beautiful to just share space in those conversations, and for me to know all the back end political crap that will block an innovation from reaching the market or not, try to figure out which ones can we actually like push forward despite all of that, is remarkable. So I loved it. That was one of the best 2.5 years of my life, was living in Japan, traveling the region, and seeing how our products are being used and imagining where could we go next in surgery. It's so cool. Let's check out this last one. I think we got like 4 left.
And that's where I think, again, I'm going to give advice to everyone who's out there. Be insanely curious, but not just about the engineering, about the patient and the patient impact, the patient journey, how the hospitals work, how surgery works. Why does anatomy, why when I cut here does it matter?
Mm-hmm.
It's important to understand machine tissue interaction.
And what I would add to this, absolutely yes, and all that from Steve. Underneath that, though, you can't get to that point of understanding the needs of the clinician and that machine, certain clinical interactions and all those things until you can overcome your own insecurity of not knowing and being able to ask. That was one of the hardest things I had to figure out going into the field with my sales reps, is realizing I'm going to attend a surgery where I've never seen a colorectal procedure before, and I don't know what I can and can't ask from a question perspective, but just nurturing the curiosity and also being willing to fall on my face and ask a question, be like, is this a good question? Is this an opportunity, or is this just normal surgery? Like, when you're starting to do what we call ethnographic research, which is understanding the culture of a people group or clinicians, you have to recognize that you don't understand the culture to begin with. So everything might seem special and some things are just routine. And you're going to fall on your face as you're asking these questions until you've seen it enough and had enough dialogue where you start to recognize, oh, this is really distinct. This is really special. Why did you do that there? When we're talking about the circular stapler and that whole procedure, I noticed that there's this really critical step. When this anvil right here was being loaded into this portion, prior to it, all the energy was kind of upbeat and happy. Everyone was chatting. But then when it progressed to this part and the surgeon was suturing right around the base of the anvil, he moved slower, he breathed heavier, the whole room was quiet. And in the post-operative interview after the operation, I was asking him, like, hey, did you notice the change in energy, the change in focus during this part of the procedure? He's like, no, I was completely unaware. And I was like, well, this is what I saw. Why do you think you were responding that way? And it just opened up this amazing conversation around the risk of, like, if this doesn't go right, this is where patients end up having like another surgery. And you're resecting, you only have so much colon left. So if you screw this up, there's not much more you can connect. So if it's a really lower anterior resection, I think it's what's called, if it goes really low, you only got one shot at it before someone ends up having to use I forgot the word. It's like a bag. Like, you have to poop into a bag for the rest of your life if you can't connect the tubes. I saw one procedure where they were not able to finish this as planned because of other complications. And someone went into surgery thinking they're going to have all of their tubes connected, and they come out of surgery with something coming out of a bag on their body for potentially the rest of their life or not. So super high risk. And you only discover that by being able to lean in and be proximal and pay attention and be curious, as Steve was sharing. Let's see. Speed.
I can't do this alone. I'm good, but I'm not that good. I'm going to need some engineers, and and this is where we come back to what I said before about the connections a little bit. So I'm going to say, okay, I would be saying, how do I make my ultimate hit team?
This was so big for me because I don't know what my future looks like. I've been, I progressed surgery for a decade at Johnson & Johnson. I went into the startup scene. I did my own company. I have a community and a platform called Skool where I help people build the lives they desire. It's super cool and nerdy and weird. But I do love the idea of building companies in the med tech space in the future. And having your eyes open to what that hit team could look like is something I think about more and more. Like, I think about, I would totally bring in Demetrius if I was starting something. I would totally bring in Amanda. I got emotional about it for a bit. There are certain people I would bring in to a company I was founding because they're exceptional and they care, and it's the people that move the technology forward. So as you're thinking about your own venture someday, like, think about who you want around you because you're going to spend a lot of time with them. That was a great insight from Steve. Let's see. It's so beautiful. So, do a lot of people get this wrong?
Oh, yeah, 90%.
Yeah. Yep. Yes, they do. That's the innovation trifecta as well. And then last one.
Things, live where you want to live if you can. You know, don't go and live in a rainy, miserable city that you just hate in a language that you don't know. Why? Because you'll be miserable, and you're doing this to be happy. So why make yourself miserable?
Such a beautiful insight, beautiful hook for us to land this discussion. If you want to continue to connect with me, if you like conversations like this, you're welcome to comment on the video, which is super helpful. But I'd also encourage you, I have a free community where I provide an assessment to help people live where they want, love what they do, and be paid well for it. It's not synthesizers. It's called the Big Brain Club. And we have a new member. Oh, that's awesome. So basically, I help people with left brains, like engineers, global leaders, right brains are the creatives and community builders, and whole brains are parents and entrepreneurs. And I provide them this assessment that baselines 3 parts of their life so that they can intentionally then build the life they desire. First of which is how undefined is their journey? Do they have a lot of unknown unknowns that they're facing? How disorienting is their journey? Do they know what the next right step looks like? And how isolating is the journey? Do they have a community around them that could support them and that has seen the level of success they aspire to? And then the community wraps around them and pushes their life into the green in the days and months to come. So to show you a cool example of this in the clinical space, if we go into community and we go into Pro Brains, this individual is a member of my paid community, but this is free. This is a doctor. So she had this experience during residency where she was navigating a severe wound and it led to a poor patient outcome, and it set her on a path towards understanding wound care and healing. And now she has a community called Wound Fit on this platform called Skool, where she's helping educate other clinicians on how to care for wounds based on who they're serving. She's in geriatrics, which is elderly patients. And then she shares her desired future state, like the life she's trying to build with her business, why she wants this change in her life, what she's afraid of, her assessment. And then the community can wrap around her and support her on her journey, and we all kind of push her forward together. And I have office hour calls with her once a week as well. But it's been really exciting to build this community. It has a really eclectic group of big brains from a wide range of disciplines, and we're all just trying to build remarkable lives. So we're not living, as Steve said, in a miserable, rainy, sad city. So I guess no Seattle for anybody. But anyway, I deeply appreciate you. If you want to join, I will share a link and then you can hop right in and hang out with cool people. And thank you for being part of my journey as an entrepreneur as I try to integrate fatherhood, entrepreneurship, and progressing new innovation from a medical perspective, whatever my next looks like in that space. So keep changing the world. You can sip on that, and I will see you on the next one.